Hello, class. This is going to be the first video from section 6.4, logarithmic functions. Um, and for those that regularly watch my videos, I'm going to try something a little different this time. Normally, I just do like one big block video, maybe two, depending on the length. Um, because I don't know, I'm used to doing it in a lecture format, and so like a one long lecture kind of flows. And to be honest, it's less work dealing with one video than like five or six. But I'm gonna try to do shorter videos. Maybe that'll make it more and watchable for y'all. So we'll just see how it goes. All right. So 6.4 logarithmic functions. This is what I would call the core section of Unit 4. We did 6.2 inverse functions, 6.3 exponential functions. Those were both warm-ups, so what we're doing with log functions. Um, but 6.4, 6.5, 6.6, if you don't get the core idea of what a logarithm is, then you're not going to be able to pass this test. Right? And part of the reason why I'm stressing 6.4 so much is that when I ask this in class, like who has dealt with logarithms before, usually I only get a handful of people, maybe sometimes even just like two or three. And so for the vast majority of the students in my classes, this is a brand new operation. Okay? And how long has it been since you've learned a new operation in math? Elementary, maybe junior high. And so when you're learning new operations, you just have to practice over and over again. It's kind of the way that we learn. If you ever look at any neuroscience, when we're learning, our neurons are firing from one to another, um, and if you don't, if those neurons fire like just once, then that connection decays away. But if those neurons fire multiple times, the same neurons, then basically you're building up a pathway that's harder to degrade. And so then, that's how we learn and how we remember things. It's sort of like I don't know. Have you ever been someplace where they set up a new sidewalk and people don't want to walk on the sidewalk? They have a path they want to walk. Like in the first couple of people that walk across it, the grass will you'll will bend over, but if they like nobody walks it, then the grass will recover and it's just like they never walked across it. But once several people start walking it regularly, you start wearing that path in there, and then eventually, that's a full path that everybody can see and walk. And so that's almost sort of like how you learn is you have to do this stuff over and over and over again until hopefully at the point it becomes almost automatic. Okay. So that's one reason why 6.4 and 6.5 have so many homework questions in them is you just have to practice with logarithms if you've never seen them before. Okay, and at some point, hopefully they'll start to there's like a rhythm to logarithms. I'm not trying to make a pun there, but it that's the way I would describe it. And once it starts clicking, then you'll be okay. But until it starts to click, it's still until logarithms start to make sense. This can be a very um, stressful section because, like I said, it's not something you've dealt with before for most of you. Okay. And sorry about the glare. It's this office. I don't know what it is. During the day with bright sunlight, I've got the glare behind me. And then I get in the evening when I don't have the sun, and then the lights glare no matter what I do. So I may have to, I don't know, move my desk around, paint the walls different color or something. But let's go to the camera. I also noticed that if I try to do a background to like get rid of the blur, then I can't use my camera. So let's go to the notes and so this first part, I'm just going to focus on what is a logarithm. All right, so logarithmic functions, and you can see why we normally call it logs. Just just a short, that's a mouthful to say. But logarithmic function is the full term. We're just going to call them logs. And so, what is a log? So, what if I say log? And let me just write it down, and then we'll talk about it. Okay. So, when you see this. Okay, so that is a subscript. And when you're reading this, you should say log base 2 of 8, okay, or whatever it is. So one of the things that I'm very particular about, particularly in class, where I can actually get the feedback, is anytime you're saying that base, say the word base. Because if you don't say the word base, because well, in your brain, when you hear base, that tends to force this down into the subscript, which that's a subscript, not up here with a log. But I found that people who don't say the word base, what tends to happen is that or whatever the base is, tends to drift up to where the eight is, and then the eight would drift up to an exponent. Okay, and that's not what we want. And another thing on logs is I really wish we would put parentheses around that argument. Mathematicians, we can be a bit either a bit lazy or concise, depending on how you feel, of not putting things when we don't need them. And we know that's the log base 2 of 8. Since it's of 8, we in our brain we don't need the parentheses. But when you're first learning logarithms, I think it would be really helpful to put those parentheses around the argument, so that forces you to think of it as a log of something. The closest we have notation-wise to this is probably radicals. So like you have square root of something, cube root of something, fourth root of something. But that something is always inside the radical. So you don't really need parentheses because the radical takes care of it. Right? But until you get comfortable with logs, I highly recommend putting parentheses around what you're taking the log of. Okay. But just get in the habit of saying the base and then saying, of whatever. And so what does this mean? Yeah. Well, it's a new operation, so you're not supposed to know what it means, right? Well, the way that we're going to deal with logs is we're going to connect it to its inverse operation. That like, how did you first learn division? Well, division was backwards multiplication, right? And so one way that you learn radicals is square root is the opposite of x squared. Well, the inverse or opposite operation of a logarithm is its corresponding exponential function. And so this is in those notes. All right, so what you have to be able to do, and like I said, this is like the key to everything in logarithms, is if you have log base b of x equal to y, this is equivalent to, and when we do that double arrow, it means equivalent to because it goes both ways. So the way that you convert a logarithm to an exponential expression is the base of the log is the base of the exponent. So this is going to be b to some power. And now, if hopefully you've done your 6.2 homework, the inverses, and one of the themes and inverse functions is you swap the x's and y's. Okay. So now instead of x being with the b, the y should be with the b. That's going to equal x. So log base b of x equals y is equivalent to b to the y equals x. And once we start putting numbers in here, you'll see that our brain tends to to be okay with the exponential function. We're much more used to thinking in terms of add, subtract, multiply, divide, but exponents, since they're kind of repeated a multiplication, aren't that bad. But that's something that you're going to have to do, especially in 6.4 and 6.5, 6.6, is, and we already talked about this in 6.3, start thinking in terms of powers. And instead of 2 times 3, 2 times 4, 2 times 5, now you want to think, 2 to the third, 2 to the fourth, 2 to the fifth. So we're thinking in terms of exponents. Now, a couple of the things, so like I said, to be successful with logarithms, you have to get this down. And I've been doing logarithms for, I don't know, maybe 40 years, almost 35, 40 years. And to this day, I still comprehend logs by converting to exponential functions. It's just I've done it so often that in my brain it's automatic. So I don't have to consciously think about converting them. But that's still how I think of logs, is what's the equivalent exponential expression. And the reason this is a double arrow because it goes both ways. So we can take any log expression, convert it to exponential, any exponential expression, convert it to a log. Yeah. And we're going to have a lot of examples on that. But right now we're just kind of establishing what is a logarithm. Right. A couple other things about logs is just as a note that the argument, which the argument is just whatever we're taking the log of, in this case x, has to be greater than or equal to 0. Okay, so we cannot take the log of 0 or a negative number. We're going to talk a lot more about that. That's basically the domain, with x. We're going to talk about that a lot more when we do a little bit of graphing towards the end of this section. Okay, but that comes into play with the domain. So no log, just like we can't take the square root of a negative number with logs, we can't take the square root of a negative number or zero. Something else is the base has to be greater than zero, and the base cannot be equal to one. Which that's those are restrictions we had for exponentials, right? So the base had to be greater than zero, the base couldn't be equal to one. Well, if that applies for the base with exponentials, it also applies with the base for logarithms. Okay. So that restriction is nothing new. It's just our base is in a different spot in our function. Okay. All right. Let's see. What are some other? Okay, so here is, how do we convert between logs and exponents? Okay, and this is where, like, so we're going to do a lot of examples with this, but here's sort of the what you're going to be doing over and over. So to convert between a log and exponential form, so the base of the log is equal to the base of the exponent. Oh, I already talked about this. So base of the log is equal to the base of the exponent. And then you swap for all, as with all inverses functions, swap the x and the y. So that's in the didn't really, I'm just reinforcing this. So the base stays the same, and then basically what's happening here is that answer to the log becomes the exponent. And so that's another way to think about logarithms. Logarithms are exponents. Okay. Because that log base b is equal to y. Well, where's y? Y is in the actual exponent. So anytime we're finding logs or answers to logs, we're finding exponents. And so that's a little something to keep in the back of your brain. Okay. So a couple of the things about what logarithms are. Yeah, I talked about, I really wish that we would and initially put parentheses around the argument. So in the notes, when I first start doing examples, even though the examples aren't going to have parentheses most time, I will put parentheses. MATLAB should accept them either way, but that just really kind of helps separate out what's the log and then what's the argument. What else? And I'm just following along with my notes. So there are two main bases that we have for logs. Is base 10, that's what we'll call a common log, because our number system, our Indo-Arabic number system is base 10 to begin with. And so that is, if you see a log without a base, so if I say like log 50, that is understood to be 10. Sort of like with a square root, well, we don't put the 2, but if it's a cube root, we have to put a 3, or a fourth root, we have to put a 4. So if you see a log without a base, you have to remember that it is base 10. The other regular base that we deal with, or main base that we deal with, is something called base E, which is a natural log. That's the name of it. And so what is E? Well, if you haven't dealt with logarithms before, you probably haven't dealt with the letter E. Um, and there is a mathematical definition of what E is. To me, E is like pi is one of those magical numbers in math that shows up in geometry with circles. Pi is a number a little bit bigger than 3, like 3.14. Well, E is a number, and it has a mathematical definition, which you don't need to know unless you're going to calculus. But E is 2.718. And actually, this goes on, just like pi goes on forever without a pattern, E goes on forever without a pattern. Okay. So, and the reason that we're going to talk about E a fair amount is, the pre-calculus part of why we're doing all this is E is a very common base when we're dealing with logs and calculus. And so just remember, E is a number a little bit less than 3, 2.718 is what I remember. You don't have to know where it came from, you just have to know kind of what it is. All right. And so the one thing that trips people up when it comes to E as a base is we could write log base E of X, but there's actually a shorthand notation, and that's ln X. That is not a lot of people think that's a capital I and an N. That's not a capital I, that's a lowercase n. Sorry, lowercase L. And the reason it's ln instead of nl for natural log is this is back when they were developing calculus, French was one of the languages that was used a lot. And in French, they have their adjectives backwards. So it was log natural instead of natural log, basically. And the reason these are important is if you go to your calculator, your calculator has these two bases in it. So when you see that log button without a base, that is log base 10. That ln button is log base e. That's our natural log. Okay. Now, some of your fancier calculators may be able to, will probably be able to let you put different bases in, but we're not going to deal with that. There is something called a change of base formula we'll deal with in 6.5. But we're focusing more on like being able to use this conversion rather than do it in the calculator. So what little calculator work we will do will be with either base 10 or natural. Okay. But those are the two main bases that get used in math outside of these couple of sections where we're just learning what a log is. All right. So in summary, what is a log? A log is basically an exponent. And the way that we have to think about logs is we have to be able to convert logs to exponential expressions and vice versa. All right, so I think I'm going to go ahead and end this video now, and then because I want to do a series of short videos. So the next video will be all about examples of how to do this. All right, I'll be right back.